So here's another practice problem with STL containers for you. Um, how about you try to redo the programming assignment 2 using vectors instead of a dynamic array? So you insert some randomly generated events into both the versions, the version using the dynamic array and the version using a vector. And then you look up events in both of those versions and see if you notice any performance differences. Now let's talk about the concept of iterators in standard template library. Iterators are a means of accessing elements that are stored in STL containers. And these are very much like pointers as you'll see shortly. So let's say that we have an STL container that contains these values 13, 43, 12, and so on. And the last value is minus 19. Now with an iterator, you initialize it and it looks like it is a pointer. And the questions that you want to ask yourself in terms of the qualities or the type of this iterator is, do you want to just read the values stored in this container? Or do you want to use this iterator to modify the values as well using this iterator, this pointer? And the next question that you want to ask yourself is, do you want this iterator to be able to move forward? Or do you want it to be able to move backward? Or do you want it to be able to move forward as well as backward, or want it to be bidirectional? So all of these questions you need to ask yourself when you want to work with an iterator. And this matrix is a useful way to visualize or think about the kind of iterators that STL provides. So on the vertical axis, you've got the iterator types of whether it moves forward or in reverse. And on the horizontal axis, you've got the iterator capacities or capabilities of whether it can just read from the container or it can also write to the container. Now, if you have an iterator that can move forward and it can read from the container, it cannot write to it, then the iterator that you have is a so-called input iterator. And if you have an iterator that can move forward and it can write values to the container, then the iterator that you have is called an output iterator. And if you have an iterator that can both read and write, and it can move forward in the container, then the type of iterator that you have is known as the forward iterator. And if you have an iterator that can both read and write to and from the container, and it can move forward as well as reverse, then the iterator that you have is known as a bidirectional iterator. And then there's also a random access iterator, which we'll probably talk about later. So let's go back to Visual Studio Code and see how you can use iterators. So for that, I have defined this function named iterate vector. And we need a vector in order to be able to use an iterator on it. So I create a vector of size 5 and all of its values are initialized to 10. And then I have this for loop, and in this for loop, I'm neither using the int I equals 0 type of syntax, nor am I using the modern C++ range-based for loop. This particular for loop is using the C++ STL iterator. So pay attention to this part first. Now, this is saying that I have an iterator which operates on a vector of type int. So all of this syntax basically means that you're talking about an iterator that iterates over a vector of type int. So at this point, you might be wondering whether this iterator type is forward, bidirectional, or reverse. So this happens to be a bidirectional operator. So you can read from the vector using this iterator, you can write to it, you can move it forward or backward. I am initializing this iterator to the beginning of the vector named numbers using the statement it equals numbers dot begin. So begin is a member function of the class vector that returns to you an iterator that points to the first element in the vector. And then to move it forward, I can write plus plus it or it plus plus. So that's the forward movement. And here is the for loops part that is the terminating condition. We stop when it reaches the value numbers.end. Now, end is a member function of the vector class that returns an iterator to one element beyond the end of the vector. Remember that one element beyond the end of the vector. So, if the iterator it has reached beyond the end of the vector, then we stop. And if that is not the case, we see out the value that iterator it is pointing to. And here is your indirection operator star. Remember that we said that iterator is like a pointer, and you dereference it using the star operator. Over here, I'm displaying a new line, and then I'm saying that now we're going to iterate over this vector in reverse. And in order to iterate over a vector from the end towards the beginning, you don't initialize it to numbers.end because that is one element beyond the end of the vector. Instead, what you can do is you can initialize it to rbegin. Now, rbegin is a method that returns the iterator pointing to the last element in the vector. How are we defining this iterator it? We are setting it to std colon colon vector int colon colon reverse iterator. So now we want this iterator to only be able to move in the reverse direction. And notice that we are still doing plus plus it rather than doing minus minus. Uh, the plus plus it, since this is a reverse iterator, it automatically understands that I need to move in the reverse direction to the next element. And then you still have that indirection statement and a new line being displayed. And in the main function, we're going to go ahead and uncomment the call to this particular function. And then we will switch over to the terminal. We'll clear the screen, recompile the program, run it. And over here is the function call and its corresponding output. We're creating a vector and then navigating it with an iterator. Here's where we were iterating over the array in the forward direction, and here's where we are iterating it in the reverse direction. We don't see any difference because all of the values are the same. But if we were to change one of the values in the vector, then we would certainly see a difference. Let's go ahead and do that. In fact, let's go back to the iterator function. And once we have initialized the vector, let's modify one of its values to be equal to, let's say, 0. Let's modify the first element to be set to 0. Now you'll notice that you can work with vectors as if they were arrays using the indexing operator. And that is a valid observation, and that is a great convenience. So let's see. I've saved this program. Let's go ahead and compile and run it. I'll clear the console once again, recompile the program, and run it. And sure enough, now you see in the forward iteration that 0 is displayed first, and in the reverse iteration, 0 is displayed at the end. So that is an example that covers iterators with vectors. So that was an example that showed how you can use iterators with vectors. Now here's a practice problem or a programming challenge for you. Can you use an iterator to double all the elements in a vector of type int? So try that out at your convenience. I'll summarize what we've discussed so far. We've seen that std colon colon vector is a very flexible general purpose container defined in the standard template library. You can store elements of predefined data types or even user defined data types in this vector. And it resizes itself automatically as you add more elements to it using the pushback function or the clear function and so on, or the pop back function, you can uh, pre-allocate the vector to be of a specific initial size, and that has very important performance implications. If you initialize your vector to be of good enough size, big enough size initially, then your program is going to run more efficiently versus if you initialize it to be too small and then as you add data to it, the C++ runtime has to reallocate a new vector for you and then store the elements on it. It also provides support for common operations like indexing or appending to the end of the vector, removing from the end of the vector, and so on and so forth. There are a whole bunch of methods defined for the vector class, and you can look at those in the C++ documentation.